Hi guys, today I'm going to talk about iron regulation and hemochromatosis. So hemochromatosis is the disease when you have excess of iron which is stored in different tissues of the body as hemosiderin, right? That is the sign and symptom which are produced due to the abnormal deposition of iron in different tissues called hemochromatosis. So it is autosomal recessive disease which is due to the uh, a mutation of the HFE gene on chromosome number 6, right? So before understanding this hemochromatosis or the regulation, we need to understand about the normal. What is normally happening? So I draw over here the normal. What is happening when you have eating iron or when you have iron in your food? How it is reabsorbed and all that. Here I have drawn your intestine, as you can see over here. So this block is showing that I zoom out this area over here. So these orange color, these orange colors are your enterocytes. These are showing, I'm showing the enterocyte cells over here, right? So these are the enterocyte right over here. And this purple color is your divalent metal transporter. So these are the metal. I'm just naming first so you can understand. This green one is your ferroportin, right? This pink one I'm showing over here is your hepcidin, right? Hepcidin molecules, or you can say hepcidin. So what is happening? So this blue one is your transferrin, and this is your protein right over here, the black one. Let me highlight over here. So this is your HFE protein, right, which sensing the iron. Either it is low, either it is high, and it is basically sensing the iron level in the blood. If the body need more iron, our body don't need iron. Okay, so what is normally happening? So over here in the red I show you that these are the iron, right? In the intestine over here, I make it over here. So iron, when we absorb from the food, why? When the body sense that there is a decreased iron, it will cause this increased iron absorption from the food through this DMT1, which is your divalent metal transporter 1, which reabsorb the iron. From this, iron will be come into your enterocyte, right? So then enterocyte will be secrete iron into the blood, right? Into the blood through this channel, which is called ferroportin. Ferroportin, right? So what is happening? This iron then it is attached to the transferrin, right? Transferrin is the protein right over here. It is present like this, you can say like this. It will attach the iron with it, right? It will attach iron. Let me draw this red, this red, this red, this red. So this transferrin then move in the blood and go into the to go towards the liver. So over here, this transferrin taking the iron is coming towards the liver, right over here. Iron right over here, the iron. So transference come over here, interact with this protein which is called HFE protein. So HFE protein, what it causes, it internalize this complex which is the transferrin iron complex, right? So then iron will be stored inside the liver, right? So what is happening next? Liver then release the hepcidin, right? So over here, this one I show the hepcidin. So this pink one, they are hepcidin. So liver, when it internalize the transparent iron complex, it stored iron in the body. Let's say iron is utilized and then the body senses we don't need the iron. Then what is happening? Liver will secrete hepcidin. Hepcidin is then doing what? This hepcidin, let me change the color so you better understand. So this hepcidin, which is pink one, it causes inhibition of these ferroprotein, right? It normally causes inhibition of these ferroportin by saying that we don't need excess iron. So don't throw the iron into the blood from the enterocyte, right? It is normally inhibited by the hepcidin, which is produced by the liver when your HFE protein internalize the transferrin along with the iron complex, and iron is stored into the liver, right? So what is happening in hemochromatosis? This protein, which is HFE protein, right? So this protein, this is basically mutated. HFE protein, it is mutated. So when it is mutated, it basically cannot sense that body need the iron, I body don't need the iron, right? So what is happening? You basically need don't cannot like body cannot sense that it need the iron. So what is happening? The liver will be stop releasing the hepcidin. When you don't hepcidin, when the liver don't decrease the hepcidin, what is happening? These ferroporotin channel, they remain activated. These dark green color channel, which is ferroporotin. So ferroporotin will be remain activated. So it keep getting iron from the enterocyte into your blood, and that iron is then go to the different tissue, right? Ferritin in the form of ferritin, it is go and stored in different tissue in the form of hemocysteine. That lead to the hemochromatosis. Over here, this picture, if you pay attention, right, the same thing. This is your HFE protein, which is mutated. Now, this HFE protein, it is responsible for the internalization of this transferrin and iron complex, right? So, what is happening when you have like this protein is mutated? It cannot sense. So, what will be happen? The end result is it decrease the hepcidin release. So, what happened when you don't have hepcidin? This protein is basically remain activated because normally hepcidin causes inhibition of this protein. But when you have decreased hepcidin, this protein remain activated. It keep iron absorption. Iron will get into the blood. You have iron overload, and this iron will be stored in the form of hemocysteine, which produces the symptoms in different organs. What are the organ? Liver, pancreas, skin, pituitary gland, joints, and all that, which produces this symptom. So that is the whole story about the hemochromatosis. And the final thing is one, your ferritin level will be up. So labs are very important. That's why how you diagnose. Your ferritin will be go up. So ferritin will be go up. Your transferrin will be go like it will be super saturated, right? Because transferrin will be super saturated in this case. So transferrin will be high, your ferritin will be high, your total iron binding capacity will be low, right? That is how it is sensing that you have increased iron load in your body. Hope this topic helped you. Thank you so much, guys.